Okay, in the last video we derived these two half-angle formulas for sine and cosine with this very important note that whether it's a positive or a negative result is going to be determined by what quadrant the angle A over 2 is in. Okay. So in this video I just want to practice using them. So let's work through this first example together, and then I'll give you one to try where you can pause the video and try it on your own. So I want to find sine of x over 2. And I'm told that cosine of x is negative 1/5. And I'm told some information about where x is. Okay. Now, notice, if that's where x is, I could take this and figure out where x over 2 is. So this is basically telling me that x is in quadrant 2. Okay. But if I were to divide through by 2, and I'm going to use the fact that dividing by 2 is the same as multiplying by 1/2, I would get this. That x, oh dear, I grabbed the wrong marker here. Here we go, this is better. X is going to be between pi over 4 and pi over 2. I'm sorry, x over 2, my bad. X over 2 is between pi over 4 and pi over 2. Well, pi over 4 would be here, pi over 2 would be here. That's just telling me that x over 2 is somewhere in the top part of this quadrant, but that's quadrant 1. So x over 2 is in quadrant 1. Okay. So sometimes you will be given this. You'll be given some information about x. You've got to manipulate that to get some information about x over 2. Okay. But now I can say, okay, let's use the half-angle formula. So I'm calling it x instead of a, but sine of x over 2 will be positive, and that's because we're in quadrant 1. I want to see some work to justify that. Okay? So you're not flipping a coin and just picking one of the signs. You're identifying explicitly what quadrant your angle is in. So I've written that down. I've said that's my reason that I'm choosing the positive, and it's the square root of 1 minus cosine of x. So minus a negative 1/5 all over 2. So that's going to be the square root of 1, which I'm going to just write as 5/5 plus 1/5, because the two negatives will cancel, all over 2. That's going to be the square root of 6/5 over 2. I don't want to have that complex fraction, so I'm going to just use the fact that dividing by 2 is the same as multiplying by 1/2. Or if you prefer, you could have written that as 2 over 1 so that we're flipping and multiplying. Okay. So that will cancel, so I'm getting the square root of 3/5. Now, I've still got some simplifying to do, because we're not supposed to have fractions under radical signs if things are in simplest form. So this would become the square root of 3 over the square root of 5. And then I don't like having radicals in the denominator, but now I can deal with that, because I can multiply by 1 in the form of root 5 over root 5. And that's going to give me root 15 over 5. That's as simple as it gets. I don't have any roots in the denominator. There's nothing that I can pull out because there are no perfect squares that go into 15. And I can't cancel because I can only cancel stuff that's outside of a root with other stuff that's outside of a root. And there's nothing on top that's not under the root. So that would be my final answer in this case. Okay, so I'm going to give you another problem to try. I want you to find cosine of x over 2 if sine of x is equal to negative 1/3 and 3 pi over 2 is less than x, which is less than 2 pi. So, similar to the last problem, but I'm going to point out this one's a little bit trickier. Okay. And the reason it's a little bit trickier is because in both of these formulas we needed to know what cosine of the angle was. And here I didn't give you cosine, I gave you sine. So I told you what sine was, and I gave you this information. This tells me where x is. I'm going to need to use that together with the fact that I know the sine of x to figure out what cosine of x is. Then I'm also going to need to divide this through by 2 in order to figure out where x over 2 is, in order to be able to determine whether I should take the positive or the negative square root. Okay, so just an extra step in this one. So pause the video, see if you can work that through on your own, and then tune back in and we'll work through it together. Welcome back. Okay, so I'm going to start by finding cosine of x, because I can see that's what I'm going to need. Again, here I'm calling it x. In the formulas I called it a. That's just a name. I'm looking for cosine of half the angle. I'm going to need to know cosine of the full angle. So, if x is between 3 pi over 2 and 2 pi, I know that x is going to be in quadrant 4. Okay, and I'm going to let alpha be my reference angle, and I'm going to drop my perpendicular up to the x-axis, and I know that sine of alpha will be the absolute value of negative 1/3, which is just positive 1/3. Okay. So an angle and its reference angle have almost the same sine and cosine, but they can differ in their plus or minus signs. All right, if sine of alpha is 1/3, that means opposite side is 1, hypotenuse is 3, so I can solve for that adjacent side. So I know that a squared plus 1 squared equals 3 squared, a squared plus 1 equals 9, a squared equals 8, a is the positive square root of 8, and that's because I'm solving for side lengths. I always label my triangles for alpha so that everything is positive. Okay. And the square root of 8, that's just square root of 2 times 2 times 2. That pair of 2's on the inside, I can say is a 2 squared, so I can simplify that to be 2 root 2. So I know that this adjacent side is 2 root 2. So now I can say cosine of x is going to be a two-step process. Since x is in quadrant 4, I know that cosine will be positive. And then I can just take my adjacent over my hypotenuse. So that's 2 root 2 over 3. So there's my cosine of x. That's the information I'm going to need to plug in this formula. Okay, so now we're ready to use the half angle formula. So I'm going to take this inequality and I'm going to divide each piece by 2. Keeping in mind that if I have a fraction, dividing by 2 is the same as multiplying by 1/2. So that's 3 pi over 4 is less than x over 2 is less than pi. Well, 3 pi over 4 would be here, pi would be here, so that's just telling me that x over 2 is in this bottom half of quadrant 2. But that's what's significant. X over 2 is in quadrant 2 now. Okay. So I can say that cosine of x over 2 is going to be, it's going to be a negative, and that's because we're in quadrant 2. That tells me to choose the negative square root. And then what goes under the square root sign is 1 plus cosine of x, which, is right there, is positive 2 root 2 over 3, all divided by 2. Okay, so I do need to simplify. Okay, so I'm going to just rewrite that. There's a negative in the front. I'm going to rewrite that 1 as 3/3 plus 2 root 2 over 3, and then that's all over 2. So I can say that's negative the square root. I'm going to just find a common denominator here. So that would be 3 plus 2 root 2 all over 3. And then we were dividing by 1/2, but that's equivalent, sorry, we were dividing by 2, and that's equivalent to multiplying by 1/2. So I can simplify this then to negative the square root of 3 plus 2 root 2 over 6. Okay. So I'm just going to multiply out that 3 and the 2. Be very careful. I cannot cancel that 3 with that 3 because this 3 is connected to the other term by addition. I cannot cancel the 2 with that 2 because this is connected to the 3 with addition. So I have to just, there's nothing I can cancel because there's nothing that goes into both terms. So I'm going to write it like so. Okay. Now, that is going to count for our purposes as fully simplified. I do have a root under a root. We have not talked about how to simplify that and make that nicer. There is a way, but it would involve going into higher order roots than just the square root, and this is good enough. What I'm going to look for, oh, this is almost good enough. I'm sorry, I misspoke. This is not simplified enough because I've got a fraction under a radical. Oh, what am I thinking? Okay, so I do want to simplify that. I'm okay having a square root under a square root sign. Okay, it is possible, as I said, to simplify that to get something that would involve higher order roots, but that's really more complicated than we need to get into. So I'm just going to say no fractions under roots, no roots in denominators. That's what we need to simplify as far as roots. And right now that's a fraction under a root. So I can say this is negative root 3 plus 2 root 2 over root 6. And now I've got a root in the denominator, and I know how to fix that. I can multiply by 1 in the form of root 6 over root 6. So when I do that, it's still negative. Now I've got a 6 on the bottom. This was under the radical, so I can put it all under this one big radical. So we've got 3 plus 2 root 2 getting multiplied by 6 here. So that's going to be negative. I'm going to just distribute the 6. So that's going to be the square root of 18 plus 12 root 2. Oops, sorry. That's going to be the square root of 18 plus 12 root 2 all over 6. And that is simplified now. I spoke too soon earlier. That is simplified far enough. Okay, so I'm okay having a root under a root. Notice there are no perfect squares that I could factor out because while 9 goes into 18 and 9's a perfect square, and 4 goes into 12 and 4 is a perfect square, there's no perfect square that goes into both of these. So there's nothing that I could factor out from that root on the top. So that is fully simplified.